Hey guys, in this next video we're going to look at compound inequalities. A compound inequality is when two inequalities are graphed together on the same number line. Two inequalities graphed together on the same number line. And you're going to see two different types of compound inequalities. The first type of compound inequality is what we call an OR compound inequality. We call it an OR compound inequality because the word OR is in the middle of two regular inequalities. An example of a OR compound inequality would look like this. X is less than or equal to -2, or x is greater than 2. You can see the graph for this type of inequality here in the box. You'll notice that there is a solid dot on -2 with shading to the left to represent that x can be less than or equal to -2. There is also a hollow dot on +2 with shading to the right that represents that x could also be larger than 2. So any numbers that are either to the left of -2 or to the right of +2 would be solutions of this inequality. We can also write the solution to this inequality using interval notation. To do this, we just write the interval notation for each inequality separately. So x is less than or equal to -2, that interval notation would look like this. Since there is no minimum value, we would start with a -infinity and an open parenthesis. The maximum x can be is -2, so we would close this with a -2 and a bracket. That's for the first inequality. For the second, the minimum value is +2. We close that with a parenthesis because of this hollow dot. And then there's no maximum, so we end with a +infinity. For an OR inequality, we just put the word OR in between those two interval notations. So we're going to practice now with some OR compound inequalities in the following examples. To solve these, we just need to solve each inequality individually. So for number 1, I have x minus 4 is less than -7, or 2x is greater than or equal to 12. To solve this, I'm going to add 4 to both sides on the left inequality, and that's going to give me x is less than -3. Then on the right inequality, to isolate x, I need to divide by 2. And that gives me x is greater than or equal to 6. You always need to write the word in between. So I need to bring down that word OR and give my answer as x is less than -3 or x is greater than or equal to 6. Now to graph this, remember your graph is going to have two shadings going opposite directions. We'll have a hollow circle on -3 here, and we're shading to the left to represent all the x values less than -3. Then we're going to have an open circle on +6 with shading to the right to represent all of the x values greater than or equal to 6. The interval notation for this will look like the following. Since x can be less than -3, that'll be our first interval notation, or x can be greater than or equal to 6, so this will be our second interval notation. All right, let's look at number 2. Again, we're going to solve each of these inequalities individually. So I'm going to start with the left inequality. I need to subtract 9 from both sides, and that gives me 2x is greater than 8, and then divide by 2, and I get x is greater than 4. My second inequality, I need to subtract 10 from both sides, and I get 5x is less than 0, and then divide by 5 to get x is less than 0. Don't forget to put the word OR in the middle, so our answer is x is greater than 4 or x is less than 0. To graph this, I'm going to start by putting a hollow circle on 4. And since x is greater than 4, my shading will go to the right. And then I will put another hollow circle on 0. Since x is less than 0, I'm going to shade to the left. The interval notation will look like this. Negative infinity, comma 0, to represent that x is less than 0, or 4, comma, positive infinity, to represent that x is greater than 4. Notice that when I'm writing interval notation for compound inequalities, I always start with the graph on the furthest left. It doesn't matter the order that your original inequalities were written. The leftmost graph goes first, and then the rightmost graph goes second. So you should always be starting with the negative infinity and ending with the positive infinity. Okay, let's look at number 3. Negative 6x plus 3 is less than negative 15, or 1 minus x is greater than or equal to 5. So for this inequality, I'll start by solving the left side. Subtracting 3 to get negative 6x is less than negative 18, and then dividing by negative 6. Remember, when we divide both sides by a negative, our inequality sign flips, so this becomes x is greater than positive 3. Now I'll solve my right inequality. I need to subtract 1 as my first step. That gives me negative x is greater than or equal to 4, and then I need to divide both sides by negative 1. Again, my inequality sign flips, and now I have x is less than or equal to negative 4. So x is greater than 3, or x is less than or equal to negative 4. So I'll put a open circle on positive 3, and my shading will go to the right. I'll put a closed circle on negative 4, and my shading will go to the left. For the interval notation, again, I start with the leftmost graph. So this is negative infinity, comma, negative 4, closing negative 4 with a bracket, or 3, positive infinity, and I close 3 with parentheses. That's the first type of compound inequality, or compound inequalities. Now I want to look at the second type, which are called and compound inequalities. You can write and compound inequalities in one of two ways. One way to write an and compound inequality is just by replacing the word or with the word and. So for instance, I could say x is greater than negative 2 and x is less than or equal to 1. That's one way to write a compound and inequality. A more common way, though, is instead of using that word and in between, saying what two values x is in between and writing one long inequality. So I want you to think about what this inequality means. If x is greater than negative 2 and less than or equal to 1, then x is really between negative 2 and 1. So we could say that negative 2 is less than x, which is less than or equal to 1. This is saying the same thing as this, because if negative 2 is less than x, then x is greater than negative 2, and x is less than or equal to 1 is what we already have written up here. So this is just saying that x is between these two values, negative 2 and 1. This is also what the graph here in the box is saying. X is between negative 2, not including negative 2, and positive 1, which explains why all the shading is going in between. So for and inequalities, our shading goes in between our two values. The interval notation for an and inequality is a lot shorter than that of a or inequality, and that's because we're not using the infinity signs anywhere. If x is between negative 2 and 1, then we have both a minimum and a maximum restriction on x. X cannot be less than negative 2, so negative 2 is the minimum value. We'll use a parenthesis there. And then x cannot be larger than 1, so that's the maximum value, and there we use a bracket. So that's what the interval notation would look like for an and inequality. To solve these, we're just going to isolate the variable in the middle. So notice on number 4, we have 2 is less than or equal to x plus 4, which is less than 9. So I focus on the middle part of my compound inequality, and to isolate x in the middle, I need to subtract 4. In a normal inequality, we would subtract 4 from both the left and the right side. Well, in a compact inequality like this, we have both a right and a left and a middle. So whatever I do in the middle, I need to do on the far right and on the far left. So I'm going to subtract 4 from 2 on the left and from 9 on the right. In the middle, x is going to be by itself. And now on the far left, I have 2 minus 4, which is negative 2. And on the far right, I have 9 minus 4, which is 5. So this is saying that x is between negative 2 and 5. To graph this, I would put a solid dot on negative 2 because of my less than or equal to sign. I would put an open dot on positive 5 because of my less than sign. And my shading is going to go in between those two values. The interval notation will look like this. Negative 2 is our minimum, and 5 is our maximum. We're including negative 2, but we're not including positive 5. All right, let's look at our next example, number 5. This time I need to isolate x in the middle by adding 3. So I'm going to add 3 in the middle, on the far left, and on the far right. In the middle, I'll just have my x. On the far left, negative 1 plus 3 is 2. On the far right, 5 plus 3 is 8. So I have 2 less than x, less than or equal to 8, which just says that x is between 2 and 8. The graph of this will have a open circle on 2 and a closed circle on 8 with the shading going in between. The interval notation, our minimum is 2, our maximum is 8. We use a parenthesis on 2 and a bracket on 8. Okay, our last example, number 6, we have negative 16 less than or equal to 3x minus 4, which is less than or equal to 2. To solve this inequality, I need to again focus on the middle, and I'm going to have to do two things in the middle. First of all, I'll need to add 4. So that means I'm adding 4 on the left and adding 4 on the far right. So this gives me a 3x in the middle. On the far left, negative 16 plus 4 is negative 12. And on the far right, 2 plus 4 is 6. Then I need to divide by 3 to isolate x. So I'll do that on the far left and the far right. And I get negative 4 less than or equal to x less than or equal to 2, which means that x is between negative 4 and 2. The graph is going to look like this. We'll have a solid dot on negative 4 as well as a solid dot on 2. The shading is in between. My minimum is negative 4, my maximum is negative 2, and I'm going to use brackets on each. All right, if you had any questions over this video, make sure you have those written down for the next time. Until then, have a nice day. You're all wonderful people.